Given that the vectors 5i minus 8j plus 4k and 4i plus 6j plus ak are perpendicular, find the value of the constant a. The line L1 passes through the point with the position vector 8i plus 3j minus 7k and is parallel to the vector 2i plus j plus 2k. Write down the vector equation of the line L1. The line L2 has vector equation r equals 4i plus 7j plus 5k plus mu minus 2i plus j plus 3k. Show that L1 and L2 do not intersect. So I've got the summary of the question here. Show they're perpendicular. Well, these will be perpendicular by the dot product. Cos 90 will be 0. So part A then. So here 5 minus 8, 4 is that vector. Dot product with 4, 6a is equal to 0. So that's what happens if they're perpendicular. So we get 20. Minus 8 times 6 is minus 48. 5 4s were 20. Minus 8 times 6 is minus 48. Plus 4a. So here this minus 28, move that over. So 4a is equal to plus 28, isn't it? So a, move the 4 from times to divide. And we see that a equals 28 over 4, which is 7. So a equals 7 for part A. L1 passes through this point here and is parallel to this. Write down the vector equation of L. So L1, this is part B. As far as L1 is concerned, we've got the vector R is equal to the position vector 8, 3 minus 7. So 8i plus 3j minus 7k is the position vector plus lambda times the directional vector, isn't it? And that would be the vector equation of the line. It's parallel to this, so this is the directional vector 2i plus j plus 2k. 2i plus j plus 2k. There we go. So there's the vector equation of the line L1. And L2 has this equation. So as far as L2 is concerned then, R is equal to 4i plus 7j plus 5k plus mu. Just writing it down from above, copying it directly. So this is the line L2 given in the notes here. Show that L1 and L2 do not intersect. So for these two lines to intersect, L1 and L2 intersect provided their x, y and z components all equal one another at one particular point. So the 8 plus 2 lambda must equal the 4 minus 2 mu. Then the next point would be 3 plus lambda is that point, 3 plus lambda, must equal the 7 plus mu. And then the third one, the z value, minus 7 plus 2 lambda must equal the 5 plus 3 mu. Label this 1, label this 2, and label this equation 3. Let's solve these then. Let's solve 1 and 3 here because these will cancel each other out. So if we do 1 minus 3, it will get rid of the lambdas. So that gives, and we can find mu. So 8 minus minus 7 is 15. 2 lambda minus 2 lambda cancels, that's why we're doing it. 4 minus 5 is minus 1. Minus 2 minus 3 mu is minus 5 mu. So that tells us then that 16 is 5 mu. Let's move that over to the left. Is equal to minus 1 minus 15 is minus 16. So mu is equal to minus 16 over 5. Okay, and then lambda So if mu is equal to that, what does lambda equal to? We can get it from here by, let's get it from 1 and 3 still, what the lambda would equal. So 2 lambda, so this would be by 3. So 2 lambda is equal to, move the 7 over to be with the 5 to make 12, plus 3 mu. So lambda is equal to 12 plus 3 of these, 3 16s are 48, so it's minus 48 over 5, and that was 2 lambda, wasn't it? So that says that lambda, 12 fifths is 60 over 5, take 48 is 12 over 5. Divide by 2 is 12 over 10, so I'm going to write that down straight away. Tap it in the calculator if you need to, which is 6 over 5. So lambda is equal to 6 over 5, and mu is equal to a minus 16 over 5. But by 3, because 3 also needs to, but by 2, now what does equation 2 give us? 3 plus 6 over 5 must equal, that's the lambda, 7 plus mu, which is minus 16 over 5. So 15s and 15 over 5 and 6 is 21 over 5. Does that equal 7, 5s are 35, take 16 is 19 over 5. So lines don't intersect because these values are not equal.